Good afternoon, Morphlings. I'm out of the Microfactory today because we just spent Mother's Day with the fam. Happy Mother's Day to all the hardworking and hard-loving mothers out there in the world. So as promised, today we will talk about the wonders of composite materials and why they play an important role for the sustainable future. This is episode 2 of our startup journey, making and breaking carbon fiber composites. Let's go! Composites are compositions of two or more materials that complement each other. For instance, you have a promising material with a very obvious flaw, in which the weakness of this material could actually be alleviated by the presence of another material. And combining them together creates a new material with better properties. So actually, the simple formula for composites is 1 plus 1 equals 75, because the combination is at least an order of magnitude greater than the sum of its parts. That's what composites are. At Morph, we work with carbon fiber composite materials. Carbon fiber is well known to possess superb mechanical properties, 5 to 10 times stronger than steel. But the problem is that they come in the form of fiber. So because they are flimsy and pliable, regardless of how strong they are, their applications are quite limited. However, scientists have discovered that when you infuse plastic resin into this fibrous material, you attain the structural rigidity that one requires. Now you have a material that is super strong, yet extremely lightweight. But as always, there is a catch, and it's called an isotropy. The properties of carbon fiber composites are heavily dependent on how the fibers are oriented within the plastic matrix. Let's do an exercise. Here we have 3 different samples of a paper tape. One that is unreinforced, another that is reinforced along the longitudinal direction, and finally one that is reinforced in the transverse direction. Let's work with the unreinforced tape first. If we pull the tape along the longitudinal direction, you can see that it can break easily. Now let's try the tape reinforced along the transverse direction. Here, while the tape is indeed reinforced, it is reinforced perpendicular to the direction of the stress that we will apply. If we try to pull the tape along the longitudinal direction, it's still going to break around the weakest links, and in this case, the tape material. Finally, let's try the tape reinforced along the longitudinal direction. Here we have the reinforcement aligned in the same direction as the stress we apply. If we try to pull the tape along the longitudinal direction, it's going to be a difficult task. And even after a few tries, the strip did tear, but the rip stopped soon as it got near the fiber. Now, the reason why carbon fiber composites, despite their amazing properties, remain only in exclusive industries such as aerospace and automotive is because it requires heavy investment and intensive human labor to manufacture composite parts with reliable mechanical properties. Just trying to align the fibers along the direction of the load conditions proved to be quite the task. However, that is going to change in the next 5 years with us, Morph Microfactories. So you better watch out. In the next episode, our CTO Ferdinand will be talking about how algorithms and software play an important role to achieve this feat. Thanks for listening.